Remember we said before b is the sine of x. And I did that so that when we get here, I haven't solved for x, I've solved for b. Well, what's b? It's the sine of x. Now I'm going to substitute back in terms of sine, and I'm looking for x values that make that a true statement, or x values that make that a true statement. But if I take the sine inverse of sine, I just get x. The sine inverse of 1/2, again, is asking for what angle measure is the y-coordinate on the unit circle -1/2. Well, we're in quadrant 3 or quadrant 4. It's the only places the y-coordinates are -1/2. So let's draw that part of the unit circle. And the y-coordinates to these points need to be -1/2. And what we're after is we're after those angle measures. And we're after the positive angle measures most often, unless we're told differently. Well, there is, from here to here is an angle measure of pi. And if I go down a y distance of 1/2 to a y-coordinate of -1/2, that's another pi over 6. So 1 pi plus pi over 6 is 7 pi over 6. And if I continue to go around to this angle measure, I'm going to be only 1 pi over 6 away from the horizontal axis. So that would happen at 11 pi over 6. So those two are candidates. Again, I haven't been told otherwise, and we can include those endpoints, not a problem. I haven't been told otherwise, so I'm going to give values that lie within 1 full revolution of the unit circle. There is an additional x value where sine equals +1, and that happens up here on the unit circle at that point right there. And again, that's the angle measure of pi over 2. So there are 3 solutions to that function. One other thing that you might encounter is something that is quadratic in form, but it's not sine and sine, it's sine and cosine, or cosine and sine. So you need to make sure that you could use the Pythagorean identity, remember, and put sine in terms of cosine or vice versa. Here, I can't really do anything with cosine. I can't change it. I don't have an identity for me to put cosine all by itself, cosine to 1 degree, in terms of sine. But I do have an identity that would allow me to put sine squared in terms of cosine squared. The sine squared of x better equal 1 minus the cosine squared of that same x. And if these two things are equal, every time I see this, I get to write that instead. And then all I'm going to do is copy down the rest of that equation. Now I'm going to clean things up. 2 times 1 is 2. 2 times negative cosine squared is minus 2 cosine squared. Going to use some algebra and gather like terms. So we can attempt to factor. We're going to need a +3 when we add. We're going to need a -1 when we multiply. There is a negative already, so we're going to have to be mindful of that as we are factoring things here. Let's say that was a +1. Let's say that was a -1, and let's see what we've got. First gives us -2 cosine squared of x. Outside gives us -2 cosine of x. Inside gives us -1 cosine of x. And last gives us -1. That is what we need. So we have correctly factored that quadratic equation. Either that factor equals 0 or this factor equals 0. It's the only way two things are multiplied together and their product equals 0. One or the other of those things had to equal 0. So now let's just use algebra. I'm adding 1 to both sides, dividing both sides by -2. For what values on the real number line is cosine -1/2? Cosine is the x coordinate. X is negative in quadrants 2 and 3. Where is that magnitude 1/2? That's at that angle measure and that angle measure. So this is pi over 3 from the vertical. So that is 2 pi over 3, 3 pi over 3, or 4 pi over 3. Additionally, we need the angle measure where cosine equals -1. We know from our exact values that happens at pi. Again, I haven't been told the interval over which I'm supposed to find these x values, so without being told, I'm going to assume it's between 0 and 2 pi. This one is a little bit different. We have the cosine of an angle measure that equals a ratio. Now, it just so happens that that angle measure is 3 times x. So I would answer this question simply by saying the cosine of what angle measure equals +1/2. Well, just like we did a while ago, we know now we're in quadrants 1 or 4. And for the x coordinate to be 1/2, we're looking at pi over 3. Let's see, 6 pi over 3, or 5 pi over 3. So we know we're looking at the values of pi over 3 and 5 pi over 3. So theta would have to equal pi over 3 or 5 pi over 3. But notice that theta is 3 times x. So we're looking for x values. So now we have a little more algebra to do. 3x equals pi over 3. And 3x equals 5 pi over 3. So we solve this for x. That happens at pi over 9, or it happens at 5 pi over 9. And you say, well, those aren't exact values. It doesn't matter. I used my exact value knowledge in order to find the two solutions that make this a true statement. That's what solving means. So there we are. That finishes up this set of videos. So come to class next time and we'll work homework over all of the trig that we've learned in these last set of videos.